So, let's talk about AI. You hear the terms all the time, right? Artificial intelligence, machine learning, deep learning, they get thrown around a lot. And honestly, they're often used like they all mean the same thing, but they don't. So what is the real difference? And how do they all fit together? Well, today we're going to break it all down.
And this, right here, is the big question. It's the source of so much confusion, because these aren't just different buzzwords for the same technology. They're distinct ideas layered on top of each other. And I promise, by the end of this, you'll see exactly how they all connect.
To make this all make sense, we're going to use a simple but I think a really powerful analogy. Let's think about a set of those Russian nesting dolls, where each doll fits perfectly inside the next. It's the perfect way to visualize how all these different fields of AI are actually related.
Okay, so let's start with the biggest doll, the one on the very outside. That's artificial intelligence itself, AI. This is the whole thing, the entire massive field dedicated to trying to get machines to do things that would normally require human intelligence. And it's not just about walking, talking robots, it's any system that can kind of mimic thinking, from playing a game of chess to finishing your sentences in an email.
So here's our set of dolls, all laid out. You've got AI as the big, all-encompassing field. You open it up, and nested inside is machine learning. And then, at the very core, the smallest doll is deep learning. The big takeaway here is this: all deep learning is machine learning, and all machine learning is AI. It's a one-way street.
So if the big goal is AI, how do we actually go about building it? Well, if you look back, there have really been two main approaches. We'll start with the original method, which was all about programming AI with a very strict set of rules.
This is what we call rule-based or symbolic AI. At its core, it's just a gigantic, super detailed set of if this, then that instructions. I mean, this idea goes way back to the very beginning of the field. You had pioneers like Alan Turing, and their focus wasn't really on whether a machine could think, but whether it could flawlessly imitate a thinking human, just by following a set of rules.
But you can probably see the huge limitation here, right? And a self-driving car is the perfect example. I mean, how could you possibly write an if-then rule for every single thing that could happen on the road? A sudden blizzard, a deer jumping out of nowhere, a kid chasing a ball into the street. It's just impossible to write a rule for an infinite number of possibilities. The whole system is just too rigid.
So there's the trade-off. On one hand, rule-based systems are predictable and easy to understand. But they are incredibly inflexible. They just can't adapt to new situations. And that inflexibility is exactly why the entire field needed a new approach, a way to build systems that could learn on their own.
And that brings us to opening our first Russian doll. This is where machine learning comes into the picture, and it offers a really powerful solution to the whole problem of rule-based systems being so rigid.
You see, machine learning completely flips the script. Instead of feeding a computer a detailed list of instructions, you feed it a massive amount of data and just let it figure out the patterns for itself using statistics. It's all about learning from examples, not from a rulebook. One of the main ways this happens is through something called supervised learning. And you can think of this like studying for a test when you already have the answer key. You feed the AI data that's already labeled, like thousands of pictures tagged cat and thousands tagged dog, and the algorithm slowly learns to recognize the patterns that go with each label.
But what if you don't have an answer key? Well, that's unsupervised learning. This is more like being handed a giant, messy pile of photos and just being told, sort these. The AI has to look at all that raw data and find the hidden connections and patterns all by itself, clustering similar things together without any help.
And this whole thing isn't a one-and-done deal. It's this powerful, continuous cycle. You feed the machine data, it starts to see patterns, and it builds a model to make predictions. Then, and this is the crucial part, it gets feedback on how well it did and uses that to refine its own model. It literally gets smarter with every single cycle.
Okay, so we've opened the first doll, machine learning. Now, let's go one level deeper. We're going to the very core, to the technology that's behind so many of the most powerful AI systems you see in the headlines today. This is deep learning, the doll at the very center. It's a very specific, very powerful type of machine learning that uses something called artificial neural networks. These are incredibly complex systems with many, many layers, and that's where the name deep comes from. And the coolest part? The whole structure is inspired by the web of neurons inside the human brain. And this deep learning approach, this is what's powering all those incredible tools that are making headlines right now. The technology that makes things like ChatGPT possible is a very specific type of deep learning.
They're called generative models, and the name really says it all. After they've learned all the patterns from a gigantic dataset, Their job isn't just to classify something or make a prediction. Their job is to generate something totally new. Brand new text, original images, new audio, all of it created from scratch based on the patterns it learned.
So how can you spot a generative model out in the wild? Well, here's a really simple rule of thumb. Just look at what it puts out. If the AI's final output is just a number, a simple category like spam or not spam, or a probability, it's probably not generative. But if it's creating something new and complex, like natural language, a unique image, or a piece of audio, then yep, you're looking at generative AI.
All right, we have covered a lot of ground, unpacking each of these layers one by one. So let's just do a really quick recap to make sure it all locks into place.
And here it is, our full set of Russian dolls. You've got artificial intelligence, the entire universe of trying to mimic human intelligence. Inside that, you have machine learning, the part of AI that learns from data. Inside that, you have deep learning, the technique that uses those multi-layered neural networks to do the learning. And finally, you have generative models, a type of deep learning that actually creates new stuff.
And this really brings us full circle, right back to the beginning. This idea, which is based on Alan Turing's incredible work from way back in 1950, it just reminds us that this entire field, from the simplest rules to the most complex generative models, is all fundamentally about one thing: the imitation of intelligence.
So think about that journey for a second. We went from programming machines with rigid rules to teaching them how to learn, and now we're teaching them how to create. And that leaves us with one massive and, I think, really exciting question: what should we ask them to build for us next?